Hi everyone, it's nice to be talking to you for Laracon today. My name's Hammett, and really the only thing you need to know about me for this talk is I kind of love Laravel Blade. I came across it 5 or 6 years ago when I first found Laravel, and since then I've come to the opinion that it's hands down the best templating system for any backend programming language, at least that I've worked with. Especially with the things that have come out in the last year, I find myself using Blade more than ever. The new component syntax is a great way to make reusable templates with Tailwind CSS, and hide away all that class soup that people really seem to dislike about it. And tools like Livewire and Alpine.js have come along, and mean we don't even need a front-end framework like Vue or React to make interactive apps anymore. We can keep it all in Blade. Now, part of the reason I love keeping templating on the server is that you get so many benefits that you probably don't even realize when you compare it to using a front-end framework. The obvious one that most people mention is that rendering your templates on the server side is going to be better for SEO and for any other tools to scrape your site, because then those tools don't need to run a whole JavaScript engine just to see what's going on. If your app's localized, it's super easy to use Laravel's translation functions in Blade, which means that you only send users the strings that matter for this one template, whereas in a JavaScript front-end framework you typically send all your app's translations at once to the browser, which can amount to quite a lot, especially in larger apps, just so that the JavaScript can figure out what strings it needs to display since the server doesn't know that up front. You can also do things like sending the front end only the right parts of the template, even if there are different things shown based on if the user is authenticated or authorized to do something. Again, this can be pretty nice because you're not exposing things to the browser that you don't want the user to be aware of if they ever inspect a page source. Another useful thing is that you can use libraries like Carbon to reliably render dates and times without making the user boot up the hefty moment.js library just to display a date in one place, like I'm sure we've all done before. In fact, because most of the packages and libraries that we use in Blade are through Composer, they're entirely server-side, and we don't need to worry about our assets bundle size as much because we'll be calculating things on the server instead of shipping megabytes of JavaScript to the browser for it to calculate things itself. So, using Blade obviously has many advantages over a traditional front-end stack for lots of different scenarios, and I think it's important to understand what that means and how Blade works so that we can leverage it to its full potential. If you've ever used any other popular PHP templating libraries like Twig or Smarty, you'll probably already be familiar with the main thing that makes Blade a little bit different from them. With something like Twig, you end up writing a completely different syntax than PHP, and this way Twig can kind of abstract everything away. So, for example, if you have a designer or a front-end engineer writing templates, all your code in Twig is sandboxed and can't really do anything too bad on the server if something went wrong. So that approach does have its merits and a place in certain apps. But Blade, on the other hand, kind of embraces the fact that it's mostly going to be developers writing templates, so it's just a thin layer on top of PHP, like a preprocessor. And that kind of encourages you to write as much PHP as you feel the need to in your templates. That can be a great thing because it means there's parity between the back-end templating language and the main business logic of your app. You don't need to remember much extra syntax to do anything in Blade if you already know PHP. Mostly you just need to know the mustache syntax to print something, and a couple of extra powerful directives, most of which just build on PHP's regular keywords that you know. You might wonder why being able to use full PHP commands in your templating could be useful. Well, lots of people argue that we should always be formatting these values elsewhere, like using accessors or presenters on our models, or mapping these mutations in our controller before we render the view, and that's a perfectly valid way to do it, and it makes a lot of sense in most scenarios. But every now and then, you might just want to spice up a plain template that's only printing some data to HTML. For example, if we're trying to display a post, we might want to make sure the title is displayed with the preferred case, or that only on this page the body should be rendered in Markdown, so we could just call a Markdown parser to print the formatted HTML. Or shuffling the order that the posts are displayed so they're randomized each time. And I kind of think it's fine to do that kind of thing here and there if you know that you'll only ever have that happen in the one template, so you don't really need any abstraction. I feel like it reduces a lot of complexity because it keeps things in line. It gives us some of the benefits of co-locating code that we've also seen from tools like Tailwind, Alpine, and Vue.js, where we can put all the stuff that we care about to render a given template all in one file. If you didn't know, PHP actually started solely as a templating language itself, and it's still usable like that even to this day. In fact, there's some pretty big frameworks out there like E2, which don't ship with any extra templating language, just letting you render plain PHP templates. In fact, I've prepared a small plain function here with no frameworks or packages that can let us do this, with pretty much the interface that we're used to using with the view function in Laravel. But again, as we'll just render a plain PHP file with the data we pass it in, it won't give us any extra directives like Blade does. As you might expect, we pass in a view name and an array of data. When we execute the file to run the function, we can see the rendered HTML and the data that we passed into it is being used. So let's see how it works. First things first, it takes in the view name that we give it and tries to find a corresponding file for that view in the views directory and make sure it exists. If we look in the directory, we see there is a homepage.php file, which is the view we're trying to render here. And again, we can use PHP's own templating syntax to add some logic to our views if we want to. If we want to do something like rendering a partial, we can just use the view function inline again. The rest of this function essentially hinges on the fact that at some point we use the require keyword to load the file. This executes the PHP file and implicitly prints anything in it to the output buffer, and that usually just means that it's ready to be sent as a response to the browser that requested the page. But in our function, we actually want to return it as a string instead of sending it straight to the browser. So we can do things like render partials or render multiple views and not have it matter what order they were loaded. Or maybe we just want to do something with the string after it's rendered, like pass it in a middleware. To achieve that, we actually manipulate PHP's output buffer a little bit. We use the ob-getClean function to save anything already in the output buffer to a variable, which we can use to restore it later. We then start a fresh buffer for our own file to use. Next, to load the view, we actually have a closure here that's actually executed immediately, and that's because when we use the require keyword, the required file actually inherits all of the variables that are currently in scope. So by wrapping it in a closure, it's just a simple way to make sure it doesn't get any of the other variables we're using in this function, but only the arguments that we give to the closure. Then we can use the extract function from PHP to unload all the data variables we want in the view to the closure scope. So if we go back into the view and just dump all the currently defined variables, then rerun the code, we see that we actually have the key and value that we gave the function as variables in the view file for us to use. Now, to get that rendered HTML as a string, we use the ob-getClean function again to save it to a variable, start a new buffer, and then we put back whatever was in the old buffer before we did anything, so it's like nothing ever happened. And then we just return the HTML as a string. It's really that simple. And as we'll see later, this is basically how the core of Blade works to load our view files. But here we've managed to show off the concept in less than 20 lines of code, so hopefully it's a bit more digestible this way. But Blade gives us more than that. It gives us all these useful directives and extra syntax we can use. How does that work? Especially for it to then execute as if it's a regular PHP file. Well, the first thing we need to understand is that when we render something with Blade using something like the view function, it doesn't actually execute the Blade template directly. Instead, there's a compilation process it goes through first to turn it into a plain PHP file, which usually goes into your storage, frameworks, views directory. This is the file that then gets executed to render your template. You'll notice the compiled view file looks a little bit different to the original template, but you'll see some similarities in where your code is in the template. So now let's dig into it and figure out how our code on the left turns into the code on the right. We can begin by taking a look at where everything starts when we call the view function. This is the function we're probably most familiar with calling when we try to use Blade, but if we call something like the root view method, or the inertia helper function, or even trying to render a Livewire component, it's going to be doing pretty much the same thing as this. We can see the function first resolves the view factory from the container, and then calls the make method on it. And it's quite important to note that the view function actually returns whatever the make function does, which is usually an instance of the view contract and not a string of HTML like most people think. This means we can get a class back from it, and then we can call additional methods on that before it's returned to the browser if we want to. And that's another important distinction to take note of. This being called doesn't mean that the view file has been compiled and executed yet. The view is just being prepared. If we open up the real view class, we can see that the render method is where this really happens. And this itself is called in either the toStringMagic method or the toHTML method, which is part of the HTMLable contract that Laravel provides. So this function is actually what gets called when we return the view function in a controller, because Laravel's routing handlers know to actually call this method. If you didn't notice, the render function itself is public, so we can actually just call it manually ourselves if we have an instance of the view class, so that we can get the rendered view as a string if we wanted to do anything with it. But this function itself mostly defers its logic to the render contents function, which again calls the main logic we care about inside the getContents method. Each of these steps usually does some additional things too, but Laravel's internals are actually pretty well commented, so if you're curious about what else it's doing at these stages and want to dive in, these comments will certainly help you to understand some of the things that aren't so obvious. But moving on, the getContents method then invokes the get method on the engine. This is something you might not have known, but in Laravel, a view can be rendered with multiple different types of engines. Out of the box, Laravel supports obviously the Blade engine, but also one for vanilla PHP and even a plain file engine. If we go back into the view factory to look around, we'll see the extensions property maps which file extensions should use which rendering engine. So this means that in our app's resources views directory, we can put a plain PHP or even HTML file, and depending on the extension, they might not be rendered with Blade at all. As we can see, this is just a plain HTML file. Blade syntax in this file doesn't get executed, if you can believe that. If we take a look at Laravel's view service provider, we can see that the Blade engine gets registered as an instance of the compiler engine class, with the Blade compiler being passed into it. But the compiler engine class still isn't quite Blade itself. It could be used to handle additional compilation steps, or even for other syntaxes or languages if we wanted it to. In fact, if you've ever used the Ignition package, it's what provides the pretty error page you see nowadays in Laravel. That actually overrides the default engine from Laravel with its own version, so that it can do a couple of extra things on top. And notably, it uses this step to make sure that it can point you to the errors in your own .blade.php templates instead of showing any errors in the compiled view, which can be quite confusing. Anyway, we know that when we're rendering Blade files, the compiler engine is using the Blade compiler class it was passed. So now we're starting to look at Blade itself and not just the abstractions that wrap around it. Let's just clean up our tabs quickly. So the main method we're looking for here is compileString, which as we can see will compile the given Blade template contents. Before it does the real compilation, it first goes through a few additional steps. Firstly, it strips out any blocks of code that shouldn't be compiled by Blade, like anything in verbatim or PHP directives, which it could then put back in later after everything else is compiled. It then strips out any Blade comments so that they won't show up in the compiled file. Then it precompiles the Blade component tags that were introduced in Laravel 7, and it does this through the component tag compiler class. We can see this class's whole purpose is to pass these huge, complex regular expressions to work out if there are any of these tags in the Blade code. But eventually, it just compiles them down to the old @component syntax that we were used to before Laravel 7. But I would note that in some cases, like here, it actually also adds some more stuff. Like for class-based components, it'll then call the withAttributes method on it to set up the attribute bag for that component. But anyway, after it's set up these tags, the Blade compiler takes the source code through a set of precompilers. Like many other things you might have noticed with Laravel, This is yet another hidden feature that isn't documented, but it can be really powerful. It's just a way to run a set of callbacks over the source code to modify it before it goes through the main compilation steps. If you're wondering what that might be useful for, Livewire actually registers a Blade precompiler to compile the Livewire component tags to @Livewire directives, just like we saw got done with the regular Blade component tags. After it's run the precompilers, it takes the source code and runs it through the token get all function that PHP provides. Oops, I didn't mean to close that. And this is just a way to make sure that if you have any raw PHP tags in your Blade file, they won't get parsed and compiled by Blade, they'll just be appended to the compiled view without anything being done to them. Anything that isn't a PHP tag then goes through this parseToken method. This then checks if the given token is counted as HTML, which might sound confusing, but remember that normally, .php files are really just a plain HTML file until you open a PHP tag. Anything outside that will be treated as plain HTML by the token get all function, even if it looks like we've got some kind of logic in there with Blade syntax. So in that scenario, it'll try and run that code through several compilers. In order, that's going to invoke the compile extensions, compile statements, and compile echoes methods. The compile extensions function offers yet another undocumented way to extend Blade's functionality yourself. In fact, here's a practical example of something you can do with it that might come in useful. In our own app service provider, we're extending the Blade compiler, and this will essentially use a regular expression to find any of these new trim directives we've added, along with any white space around those, and strip them out completely by replacing them with an empty string. So when might that be useful? Well, we should all be aware that in a text area we shouldn't have any white space between the opening and closing tags, else that white space will actually become part of the input's real value. But using the trim directive we've defined, we can completely get rid of that white space. If we look at the rendered view, we can see there's no white space there at all. Similarly, if we take a look at the compiled view file, we can see the white space is completely gone from that too. So this is something that can't be done when we register a regular Blade directive, so compiler extensions can have their uses. This was a pretty straightforward example of what one might look like, but I'm sure we'll come up with much more useful things as we need them now that we at least know it's an option. The next compiler down the list was the compile statements method, and this is really what Blade is at its core. This is probably what comes to mind most when we think about Blade. It finds any statements that start with an @ symbol, like @if, @foreach, or even @component, and then it parses them and sends them through the singular compile statement method, which is where the magic actually happens. There's actually 3 different paths this can go down. The first one checks if the statement's name starts with another @ symbol, so for example, if our Blade file has a statement like @JSON, it won't do any further compiling on this, and it will just put the string back together. This way it can prevent Blade from compiling a directive by escaping it with another @ just in case we need to use the string of @JSON somewhere else, like in a JavaScript framework that we're rendering inside Blade. The second one it will check for is custom directives, and these are the kind of directives we might register in our own service provider with the Blade directive method. When you call that method in your service provider, the callback actually gets stored on the compiler so that it can be invoked at this point in time. Finally, the built-in directives as part of Blade's core get compiled, but we should pay attention to the order of this. Custom directives get compiled before the core ones. This means we can actually override a core Blade directive, like @if, in our service provider. If we wanted to, we could do something truly evil by only making an if statement pass half the time at random to really troll someone who's trying to debug it. Obviously, I don't recommend doing this to someone unless you're ready to make an enemy out of them, but this kind of thing is possible and it can have genuine uses. For example, if your authentication system in your app isn't using Laravel's auth guards at all, you might want to override the auth directives to work in a way that makes sense for your own authentication system. But let's go back to those first-party Blade directives again. we can see it tries to call methods on the current Blade compiler class, where the method name starts with the word compile, followed by the directive's name. All of the core directives actually live within traits on this compiler class that encapsulates a given set of concerns that it deals with. For example, if we look in the compiles conditionals trait, we can actually see some of the most basic examples, like the if directive, to let us see what the Blade directive really compiles down to in raw PHP. But you can also use this to start looking at more complex directives to see what they do under the hood, like to see how the auth one currently checks for authentication. One of my favourites is the error directive, which was added by Caleb Borzio a while back, which we can find in the compiles errors trait. By taking the time to understand this, we can actually garner a few useful tricks that will help us to write our own Blade directives, especially to work around problems that, at least I've noticed, people always get stuck with when they start writing their first custom directive. Let's start by taking a look at how this directive is used. We pass the directive a field name that matches the name of an input, and if it detects an error by that name on the page, for example if it came from a failed request validation, then it gives us this magic message variable that we never defined ourselves, but it'll always contain the right error message to display to users. Moreover, if we use this directive multiple times on the page, it won't display the same message multiple times over. But what if we did have our own message variable that we passed into the view and we wanted to use that elsewhere in the template? Would we lose that? Well, the directive source code actually handles that scenario itself. We see in the opening tag, it checks if there's already a message variable set, and then it backs it up to another temporary variable name before it sets the message variable that it uses internally, which is just whatever the error was in the error bag. But in the end error directive, it basically reverts all of that by checking the temporary variable was set, and then moving it back to the message variable. It's paralleled exactly so that if you have an opening and closing directive together, you don't get any side effects outside those. This is quite a simple and straightforward example, but if you think about that pattern and look around at other directives, it's actually used all over the place. Think about opening and closing layout sections, or components in their slots. They each need to start doing something when the opening directive is found, and then clear up after themselves at the end. Another useful pattern that I find it uses is something that I see almost everyone who writes their first Blade directive struggle with. When we write our custom directives, in the callback we actually get an argument passed in, but this isn't the real PHP value that we passed into the directive in Blade. Instead, it's the raw expression as a PHP string. For example, if we have a directive with a string of foo being passed into it, and we render that, it'll actually have the quotes around the value itself. This becomes more pronounced if we try and pass in multiple variables, where we'll see we've now got a single string with multiple arguments. If we wanted to do something with these variables in our directive, we may want to process the string in some way to make it more manageable. Something a lot of people do is try to evaluate the expression using the eval function inline. This can work for some simple cases like this. We'll see that now we have a real array of values that aren't wrapped in extra quotes. However, that's a very naive approach and it doesn't always work. For example, what if in our Blade file we defined a variable with the value and then passed that into our directive? When we try to render that, we're going to be greeted with an undefined variable value error, because at the point we're evaluating this code, the variable's not in scope, which means that it kind of prohibits you from passing any dynamic values through to your directive. Something else I see people try to do a lot is exploding the expression on commas to get an array of the different expressions, one to represent each individual argument, but still noting that they're a string. And this gets us to similar what we had before, where the strings have literal quotes around them and the variable isn't really evaluated. But maybe we can use that because we can now choose where to put each individual argument into the compiled string that we return. For a quick example, we can get that variable as the last item in the array and echo it out. And the intention behind this is that we need to remember it's still just a compilation step. So when we render the template, this will actually equate to echo value, with the value inside the template at the time. If we try this to see if it works, we can see it looks like it works perfectly, and we could do that with any kind of value in the expression, right? Well, unfortunately, that's also kind of flawed. For example, let's see if some of our arguments were in an array. It's still rendering fine right now, but if we dump the variables again, because we're being naive and only delimiting on a comma, our strings now have the array opening and closing tags on them. And again, this can get more complicated if you're passing in something like a literal string with a comma in it, or calling a function inside your directive with multiple arguments of its own. So, how do we get the individual arguments passed into the directive? Let's take a look back at the error directive and see what that actually does to handle it. It actually takes the expression and assigns it to an array in line. So that way it doesn't get evaluated at the point we're compiling the blade file. It only gets evaluated when the blade file is being rendered and that compiled view is executed. And this means that any variables or anything else it might need is always going to be in scope at the time. So let's try that again. Let me just make the window a bit wider so it's clearer to see what's going on. And let's just dump the variables again so that we can see them in line. Now we can see it's all being handled perfectly. The variable's been evaluated, the array is a real array, everything is exactly as we expect. We just need to make sure that when we need to rely on things like this, we do it at the blade runtime and not the compile time, by doing the logic for the expression in the string that we return from our directive, and not in the callback itself. If we look back at the end error directive, we see again that it unsets these variables that it originally made for the arguments to clean up after itself. If we find ourselves looking at a number of other directives, we'd notice this weirdly named __env used in quite a few places. But it might not be obvious what that is at first, but if you remember how back in the original view function we looked at, without Laravel, if we wanted to include another template as a partial, we just called the view function again in line. Well, that's basically what it's doing here. __env is actually an instance of the view factory, which it then calls the make method on, just like we saw before. If we look at the view factory class, we can see in the constructor that it actually shares the __env variable to the current instance of the view factory. So this gets merged in with the array of data that we passed in the second argument of the view function to use in our blade template. Now, we've seen how most of the blade directives actually work, and that should be a good point for you to jump into looking at them yourself if you need to. If we go back to the blade compiler and see what we were looking at before, the last compiler it calls is compile echoes, which lives inside this trait. This compiles the different types of echoing syntax Blade provides: raw echoes, escaped echoes, and regular echoes, which are each methods on this trait. For example, for the regular echoes, these are mostly just regular expressions again to replace the Blade mustache syntax with the regular PHP echo syntax. We can see it's using the content tags property from the Blade compiler, which defines the opening and closing tags for each of Blade's echo syntaxes. There's different ones for the different kinds of echo statements there are. So yeah, that's pretty much how the entirety of the Blade compilation process works, but we've still not seen exactly where it gets compiled. If we go back to the compiler engine, we should recall that the viewRender method actually calls the get method on the engine. After it's compiled the Blade syntax into a raw PHP file, it then has to evaluate it. If we look at the evaluate path method, it should look fairly familiar. This is essentially what our standalone view function at the start did, where it starts a new output buffer, and then it requires the compiled view file, which at this point is just a plain PHP file. And there we have it. From there, the compiler returns the final string of all of our rendered HTML using our templates, all the way back up to the view class. So hopefully that dive into the source has been useful, and you understand Blade a bit more now. If you're using Blade in any capacity, especially if you're writing your own custom directives or using something like Livewire, I think it's really important to know these fundamentals about how Blade works so that you can understand how to debug any problems you might come up with and make it do things that you might want that aren't necessarily so simple or obvious. But that's all I've got for you today. Hope you enjoyed the rest of Laracon.